right, so let's go ahead and get started. So, start with ODP. Any questions on the current ODP? Yes?
Like you mean for the new ODP for 305?
305, yes, the one that's due tomorrow morning.
Yeah, I already finished the 205.
You were one of the first people to finish.
Yeah.
Yay.
I used Boolean.
You used what? Boolean, yeah.
Yeah, Boolean.
That's good.
Is there any way to use is there another option?
Yes, and when you get to 306, which opens up tomorrow morning, you won't be able to use Boolean. So that'll give you an excuse to find a different way. There's lots of different ways to do it.
Okay.
So, and by the way, we have an observer today, if you're wondering why there's another person in the class you've never seen before. So she's in to do an observation on my teaching, so nothing weird. All right, so the ODP that's due tomorrow morning, it's 3:05. I call this a stateful class. And this is going to lead into what we're doing this week, which is basically revisiting something we did in Engineering 250, state machines. So everything you learned about state machines, flip-flops, state tables, all that kind of stuff, there's a software analog to all of that. And it's a really powerful way to write code. Okay, now most of the code that we've written in C in the other courses tended to be sort of procedural. Here's the beginning of the code, and we do a few things, and we read some input, and we make some decisions, and we loop back, and we do some other stuff, and eventually our program's done. It's very much driven by the inputs, right? If you know what the inputs are, you can say what you're going to do at each point. In a state machine, remember, you can't tell what the state of what the system is going to do in response to an input just by knowing the inputs. So let me do a really brief flashback to some 250 stuff. So do you remember flip-flops? Say yes so I don't feel bad. So we've got a clock, and let's just say a T flip-flop. So a toggle, it's got an input, and there's an output Q. And let's say our clock changes from 0 to 1. And let's say our T input is a 1. So we know all of the inputs of the system. When this clock rises from a 0 to 1, can you tell me what the value of Q is going to be? You can't, right? Why not? Depends on the previous value. Since my T input's a 1, if Q was a 0, now it's going to be a 1. If Q was a 1, now it's going to be a 0. But just knowing that T is 1 and our clock is rising doesn't tell us what the new value of Q is. It depends on something that already happened in the past, and that's what we consider to be the state. So the state of this flip-flop might be the fact that currently Q is equal to 0, and when it's in that state and we have these inputs, we know that Q is going to change to a 1. But if it's in the state where Q equals 1, same set of inputs, now Q is going to go to 0. So stateful code is the same thing in a software realm. Think of a function that you call and you pass it an argument, and you want to know what is this function going to do. Sometimes it only depends on the value you pass to it. If you call the sine function, if you know what value of x you're putting in, you know what this is going to do. It's going to return a number which we call the sine of x. But you could have a function where the value you pass to this doesn't completely tell you what the function is going to do. It may also depend on things that have happened in the past. Okay? And that's exactly what this ODP is going to get you a chance to play with. So you're creating a class, and it's just called states. And it has one variable that it keeps inside, and I'm calling it result in here just so we have a name for it. And result is initialized to 0. And your class has 4 methods. So the result method just returns the current value of result. Okay, so it's just an accessor. The process method takes an integer, and it does one of two things. It adds that integer to the result, or it multiplies the result by that integer. But we don't say in process what we want it to do. We don't say multiply by n or add n. We just pass n. And the behavior that it's going to take depends on what's happened in the past. So what's happened in the past is we've either called do add or do mul. If you call do add, then the next call to process will add the argument. If you call do mul, then the next call to process will multiply. So we're breaking things up in time, right? Do add does not change the result. It doesn't do an addition, despite its name. Do mul does not do a multiplication. These have no effect on the result, but they affect what happens when you call process. Okay, this is very common in real life, right? We set things up, and based on that, something's going to happen. We walk out the door of our house. Do we turn left or right? Well, it depends what day it is. If it's Monday, we turn left so we can come to Clark. If it's Saturday, we turn right so we can go get breakfast somewhere. Okay? So this is stateful. So you want to make your class with these 4 methods, and here's some sample code showing how this might behave. So you can create a new states object. If I say process 5, the default behavior is add. So it adds 5 to 0, which is the default value, and we've got 5. Process 7 adds another 7, we've got 12. And now we say, let's do a multiplication. And when we process 3, it multiplies 12 by 3 is 36. And we go back to do add, process 1, it adds 1 to 36 is 37. And now if I were to print the result, I should get that 37. All right, so that's ODP 305. Make yourself a states class, test it with your own code. When you're ready to assess, there's your usual assess line. So that's due at 8 tomorrow morning. And then tomorrow morning at 8:05, the next one opens. And this is a more stateful class. So exactly the same thing, but it has 4 states: add, subtract, multiply, and divide. And instead of having a do add, do sub, do mul, do div, we just have a do operation method now. And you pass it a string saying what operations you want it to do. So for example, I can say do op sub, and then if I say process 3, it should subtract 3 from my result. If I say do op div and then I pass it a 7, it should divide my result by 7. Everything is integer, so just let the precision fall off. Right, so there's test code, and that should give you a result of 4.
Your flag is now a string.
So your flag could now be a string. Yeah. But it probably can't just be a Boolean anymore, because we've got 4 states now.
Use 2 booleans.
Could use 2 Booleans. Could use 4 Booleans, which engineering 250, we call that one hot encoding. So everything we've done there will actually map over to this if we wanted to. We probably don't want it to. But speaking of bad flashbacks, so Google Doodle today, anybody see it? So it's Gauss's birthday. And Gauss was, one of his students was Riemann, who you've heard me talk about in here. But one of his other students, Kirchhoff, KVL, KCL. So you can thank Gauss for teaching Kirchhoff, who came up with KVL, KCL, which was your favorite topic in 120, right?
Is that the same Gauss from physics?
That's the same Gauss from physics and mathematics and
He's
philosophy
way
and
worse
everything
than
else. Yeah.
So much time.
Yeah.
Yeah. Yeah, Gauss was amazing. Yeah. And why you fold a piece of pizza when you eat it so it doesn't droop. Gaussian. All right. So that's stateful stuff, and those are your next 2 ODPs. Okay, that next one's due Wednesday morning. And it ties into everything we're going to do this week. We're going to look at stateful systems in Java. And we've already started doing this, but not so overtly. So we're going to be very deliberate in talking about states today. And we're going to do this in Eclipse. So what I'd like to do for the first half of class at least is work together to build a little calculator application. Something with a keypad, we can type in numbers. And we're not going to make it a full-blown calculator, we're just going to make it so it can add numbers. But you could extend it to do multiply, divide, and so on pretty easily. But I want to make a graphical application with 10 buttons, 0 through 9, and a plus sign and an equal sign, and maybe a clear button. And any time that we're going to do this in Swing, right? Which means we're putting up frames and buttons and widgets like that. And anytime we're doing things like that, we're doing event-driven programming. We're writing code that basically responds to actions that are happening. So let's just think for a moment about a possibly fictitious calculator. And it's got some buttons. And it's got a display. And what does the display probably have when you first power this thing on?
0.
Usually it has a 0. It could be blank, that might make more sense, but usually there's a 0, so you don't think the battery's dead. And let's say you click the button 2. What happens? The 0 changes to a 2. Now let's say you click the 2 button again, what happens? This 2 moves over and you get a new 2 over there. From here to here versus from here to there, totally different behaviors, right? In this case, we get rid of the 0 and replace it with a 2. In this case, we shift things over and pop a 2 into the right. If we did this, then our 0 would have changed to a 0, 2, which would look weird. Okay, there's a plus button somewhere. And you hit the plus button, and what happens?
You slide a plus in, or you can.
Oh, that's a fancy calculator. What about a dollar store calculator? So you hit a plus sign, you probably don't see anything happen on here. Maybe it blinks briefly. But it kind of registers this first number, but probably leaves your display looking the same. And now you hit the number 2 again, and what's your display going to say? It's going to say 2. So now it's getting rid of everything that was here and just showing you a 2. And then when you hit an equals sign, it should get rid of everything and probably in this case show you a 24. And if you sit here and you hit an equal sign at this point, you probably just still see a 0. And if you have a 2 and you hit an equal sign, you probably still just see a 2. So we only have a few buttons, but those buttons can do different things depending on where we are in this kind of process, this state transition of adding 2 numbers. So we want to think about the different states that your system can be in, and then we're going to write some code to respond to button presses for each of those states. And if we do those 2 things, we're going to have a calculator. And then you can add numbers all day long, give it to your friends, all sorts of good stuff. All right, and there's a plus key and an equal sign key. And clearly the button 2 is not magic, right? Any digit button is going to do pretty much the same thing, except the 0 button. If I have a 0 and I type a 0, my display will still say 0, but if I hit 0 again, I don't want to say 0, 0. I still want to just leave it at a 0. So there's some special case happening if our display is 0 and we hit a 0, but we'll worry about that in a bit. So let's start a calculator. So we'll say new Java project. What are we going to call our calculator? Calculator? Okay. You're not in the marketing department anymore.
The super number cruncher.
The super number cruncher, there you go. All right. So we want a J-frame, right? That's what we're always going to use for the base of our Swing projects. So we're going to say new other, and then if you haven't done this before, come down to Window Builder, come down to Swing Designer, and J-frame. And our class name, we'll call this the Super Number Cruncher 5000. And so we've got our bunch of code written for us already, right? We're never going to have to use that name, so we can make it as long as we want. We won't suffer from that. So I'm going to go to the Design tab, and we're just going to use Absolute Layout. We won't get fancy. We'll just put an Absolute Layout Manager in here. And let me make this frame a little bigger. And first thing we're going to put down is some buttons. So we need 10 buttons for our digits. So I'll click on my J button and pop this in here. And I'll call this 0. And I'm going to make this more button-like. So there's my 0 button. We want 10 of these things. I'm going to copy and paste. We could go into the code and write the code to create these things, but we'd have to place them somehow. I'm still going to use the design window to put these buttons down on our J-frame, but then we're going to start switching over to the code and working directly in the code, rather than right-clicking and selecting and so on and so forth, because it's just going to be faster. But I'm going to click on this, Control-C, and then Control-V, and make some new windows like this. Some new buttons. And there's Snap to available. So it's pretty easy to line these things up. And you get the idea of this if you do it more. Put our last button down here. All right, so we got our 10 buttons. And we want to put some code to act each time that we click one of these buttons. So let me double click one of these, and that'll bring me into a section of code. And down here I could say what I want to do when I click that button. And if I click the 0 button, I'm going to want to do something with a 0. One button's going to be a 1, and so on. I don't want to put a lot of duplicate code in here because I'm going to have 10 of these action listeners. And I don't want to write the same code 10 times. I mean, I have to, but I want to write as small a section of code 10 times as possible. So instead of putting any real code in here, I'm just going to call another method, and I'm going to pass it the argument that we have, this action event, and then we'll have that one piece of code, and we'll do something in there based on what that action event tells us was pressed. Does that make sense? Okay, so let's just make a method, and we'll just call it doKey, and we'll just pass arg0.
How did you get here?
I double-clicked on a button,
Oh, okay.
right, and that'll bring you into an action listener. It'll write an action listener for you and then bring you into that spot. Now, I can do that for the other 9 buttons, but at this point, it's going to be faster for me to just edit this code directly. And basically, each time that I have a new button, in between the construction of the button and the setting of the bounds, I want to add all of this stuff. So these 5 lines of code. So I'll just find my new button, new J button. All right, so I've written that code in there. So I've got VI, right, VWrapper. We talked about that Wednesday. So if you like VI, if you're faster with VI than you are with the mouse and the arrow keys, right, VWrapper is your friend. And I've made a bit of a mess for the moment because I just copied and pasted the same code 9 times. and it was always button 9. But up here, for example, we're constructing a button called button. We want to add the action listener to that. So in this case, I just want to run that off of the button object. And here I want to use button 1. And here's button 2. This is why you want to get good with an editor, because you'll spend a lot of your life doing these kinds of things. Of course, if we were really good, we'd just use sed. And we'd go outside and we'd write a one-line sed script, and that would do everything for us. But this works. All right, the other thing we need to adjust is all these buttons say 0. And we want them to say 0, 1, 2, 3, 4, 5, etc., right? Again, I can click on one of these, and I can come over here and come down to text, and I can change what that text is, but I can also do this directly in the code. So I'm going to do that. So I'm going to make this a 1, a 2, a 3, and so on. And so that came out a little weird. Oh, that's annoying. Well, it's a feature. I don't want to move them all. How's that? So what did I just do? I changed the problem. That's fair. All right, and when we click on one of these, we're going to come down to here, and we're going to ultimately call a method we haven't written yet called doKey. Let's take a quick look while we're here, though, at this line of code. We've seen this before, and I've said don't worry about it, right? Let's worry about it a little right now. Let's just look really briefly at what's going on here. So we're creating a J button. We're calling it button 3. And here we're saying button3.addActionListener. So what is addActionListener? What kind of thing is that? It's a method. It's a method inside JButton. And this, the stuff between here and here, must be the arguments to this method. Right? That's how you call a method. Method name, parentheses, list of arguments. Well, what is the stuff in the parentheses? It's not a number or a string. It looks like it's a constructor. We're constructing an action listener by saying new action listener. And then we're putting in a curly bracket and we're writing a method called action performed. And we've got a curly bracket, a doKey, an ending curly bracket, and then another curly bracket that's blinking right now. That's the end of the class declaration. We're constructing a class here as an argument to a method. That's legal. Okay, it's something called an inner class. It's not necessary. We could have just gone to another tab and made a new class that was an action listener, written a method in it, given it a name, and then passed that name as the argument to this action listener. But it's a lot more convenient to use an inner class structure where we actually create the class as an argument. And we don't have to sweat it too much because Window Builder's making that for us. Okay, but it's a standard construction to use, and it makes your code a whole lot tighter. Okay, instead of having what would effectively be several different methods, several different classes, each doing the same thing. So we'll play more with inner classes later on. So let's do this doKey method. So I make it private to this. It doesn't have to return anything. It takes a single argument, which is an action event, and we'll just call it A. So what is an action event? Well, if I say A dot and I hit Control space, I get a list of methods that I could call off of this. And one of these is getSource. And getSource, the object on which the event initially occurred. So we're clicking a button. That's why we're getting into this method, right? We click on the 3 button, and it goes into the action listener, and it says do key, and it passes an action event. That action event should correspond to that button that we clicked. So I'm going to say a.getSource, and that should be a J button. So I'm going to set J button B equal to a.getSource, and that should give me the button that was clicked. And it's squiggly lining me because getSource returns an object, and I'm trying to save it as a J button. And it doesn't want to take responsibility for doing that conversion. But I believe in my heart that this actually is a button. So I'm okay doing that conversion. So how do I convert from something to a J button? Cast it. So just put the type of thing you want it to be in parentheses. That converts it to a J button, and now the compiler's happy. So B, if I do a period and hit Control space, there's all the methods that I have available on a J button. And it's a long list, because remember it inherits from like several different classes. But the one we're interested in is down here under get. And you would probably use the documentation instead of just reading all of these. But we're going to use get text. And that returns the button's text. Well, what are these buttons labeled with? They're labeled with 0, 1, 2, 3, 4, 5, etc. Right? So let's call b.getText and let's save that. So let's let's just call it text. So that's the button's text. And let's print that out. So let's just try what we have so far. We've got a window, we can click on a button, and we're printing out the text associated with each button.
What was the shortcut for that system?
SYSO and then Control Enter. SYSO like sysout.
Just Control Enter.
Mm-hmm. And that'll bring up this thing, and then if you hit Enter, you'll see. Oh, but I did it out of context. Never mind. Control space, and then it'll bring up the option for print line.
Ah, that space is what.
Yeah. All right. So with this 3-line piece of code, right, we can figure out what button was pressed. And now we're ready to do some of this stuff. Okay, some of this processing. Well, let's put a display on here while we're at it. So let's put a text field over here. And let's make it big. And let's set the default text to 0. And let's use a big font. So I don't know, let's make it like 32. That looks better. And does that look like what we want for our display? What should we change? Right, justified. So we're still looking at the display. Come to the properties window, horizontal alignment, click on that, let's say right, and now it looks good. All right, so good so far. So now we got to do the state machine part. So we're going to hit numbers, type in numbers, and we're going to see them building on the display until we hit a plus sign. So let's start a state diagram. So let's call this state 1. And what are we doing here? We're entering the first number. So what does that mean? Well, when we get a character that's a digit, we're going to add it to the end of the number we've got displayed. And we're going to stay in state 1. And we're going to wait for another key press. So this is state 1. And if we're in state 1, and the user enters a digit, we're going to stay in state 1. As long as they're typing digits, we're still in the state where we're entering the first number. How do we get out of this state? What's going to change us from this state to something else? The plus sign. So if they hit a plus sign, we're going to go to a new state. We'll call this state 2. And state 2 is just going to say we got a plus sign. And when they hit a digit at this point, then we're going to go into a new state which says now we're entering the next number. But we need to know that we're in this state because the first digit they hit, we're going to clear the display, right? We're going to go from here to displaying whatever the new number is. So when we're here and we get a digit, we'll go to state 3. And this is entering second number. And again, if they're typing in digits, we're going to stay in that state. When do we leave this state, though? Equals.
If they hit plus again at this point, we want to add it for them.
We're not going to get fancy. We're going to assume it's number plus number equals. But we could augment this and say if we get another plus, we'll show the sum and we'll go back to state 2. That's going to be a really easy thing to implement, actually. All right, so state equals 4. We got our equals sign. And if they hit a digit after this, we're going to go back to our first state. So when they hit a digit, then we're back in state 1 where they're entering the first number. And there's other things we have to do along the way, right? So while they're entering the first number, we have to do some sort of display update. Shift things over, tack it on to the right. And when they hit the plus sign, we want to save that first number so that we can add it later. When they're entering the second number, we're doing a display update. And when they hit equal, we want to add and then do a display update. All right, it's making sense? So this is engineering 250, right? This is a plain old state diagram. It's got fancier words than what we did in 250 because we're not stuck with just flip-flops and AND gates, right? We have the full power of Java code here. So we're doing much more things and we're being more heavy-handed in how we make these transitions. Do we have a digit? Do we have a plus sign? And so on and so forth. But the concept, the flow from state to state, same idea as before. All right, well, clearly we need a way to know if we have a digit or not. So let's put something in here. We're not going to print our text anymore. but let's see if we have a digit or not. So if this text string called text is equal to 0 or 1 or 2 or 3, we'd like to note that somehow. So I want to have a Boolean digit, which tells us whether this text is a number. Did they hit the number key 0 through 9? So we could do this with a 10-part if statement. If text dot equals 0 or text dot equals 1 and so on and so forth. Let me offer you a shortcut. So there's a string class, we know about that. There's a method in string called index of, and I don't know if you've encountered this or not, but we can say string index of and pass it a second string, and this will return location of string 2 in string 1, or -1 if it's not found. So this takes a big string, and it takes a presumably smaller string and looks for this inside that big string. And if it finds it, it tells us the starting position of this small string in the big string. So this could be from character 0 up to some bigger number, but if it doesn't find string 2 and string 1, it'll return -1. So we can do a bit of a cheat here, and this is one that you'll bump into again and again. So there's a string, right? Since it's a string, it has an index of method. So let's find the index of our text. In other words, if we got the character 3, let's see if 3 is contained in that string. If we get the character equal sign, we'll see if equal sign is contained in that string. If the return of this call to this method is bigger than or equal to 0, we must have had a digit, because it found it in that string of digits. And if we have text equal to something that's not a digit, that index of will return -1. So we can see if this is bigger than or equal to 0 and just set our digit flag to that. So there's a one-line shortcut instead of writing 10 if statements. You can't do this in C. I mean, we could pass this string to an index of method, right? But as soon as we write this thing in quotation marks, this thing, this object, has a few hundred methods available that we can call. Substrings to lowercase, index of, etc. All right, so we're getting really, really object-minded here. So that tells us if the character is a digit. All right, we got to add a couple of other buttons here. We need our plus and our equals sign. Did you have a question?
I was just wondering if the order of operations on that was right. It was.
Normally I would throw in lots of parentheses, but I'm trying to live bravely. I don't think there's a different order of operations that will make sense, though. Right? Because it can't. I think it's going to use method dereferencing first, and then it's going to put that into an expression like an inequality comparison. You can put in parentheses, right, to be sure, but I think any other order would give a syntax error. All right, so let's put a pair of buttons here, and these I'm just going to do the non-fancy thing. This will be our plus button, and this will be our equals button. And we'll call our doKey method as usual. So we're all set. So let's build our state machine. Well, we need some states, right? So we want a variable. I'm just going to call it state. It can be an integer because I conveniently labeled my states 1, 2, 3, 4. But it could be something more meaningful if we wanted like a string. And where should we set up this state variable in this file of code? Should we do it right here?
Do you want to make it global?
We want to make it global, right? We're only going to use it in this doKey method. So in that sense, it makes sense that we could make it local to this method. But remember, this is event-driven. You hit a button, we run this code, and then it exits. And once it exits, all of its local variables go away. So since we want that variable's value to persist, it's got to be in some sense global to this class. So there's our integer state. And we can start it at 1. And I will put some comments in here. So 1, entering first number. 2, got plus. 3, entering second number. 4, got equals. So we initialize our state to 1. All right, let's do some state processing. So state 1, we're entering our first number, typing number key, number key, number key. We want to keep adding it on to the display. All right, well, we're going to need to know what's in our display, so let's save that. So again, if you hit display, that's weird. I'm jumping ahead. Let's name this thing display because it's called text field. So let's give it a reasonable name like display. And now display dot, hit a control space. We can get name, we can get selected text, we can get text. Let's just get the text. Okay, so that'll show us what's currently being displayed. That's our current display value. All right, so if state equals 1, well, if our text is equal to a plus, and remember, you can't use equal equal for strings, just like you can't do that in C. It may look sometimes like it works, or somebody noted that over the weekend in the discussions. If you define these things with literals and you say equal equal, it does the correct thing. But equal equal is saying, is this object the same as this object, not is the contents of this object the same. And if you have two literals, hello, hello, they actually both point to the same object. But if you have two strings, hello, hello, there's different objects, equal equal is going to say false. So use the equals method on the string, and this will say if our text is equal to a plus sign. So let's just set the state to 2 and return. We'll have to do some other stuff later, but let's get something happening before we hit the break. So if the text is a plus sign, that's what we do. Otherwise, if it's a digit, let's add it to the end of the displayed value. So let's display.setText. And numerically, to do this kind of thing, what you want to do is take your number, multiply by 10, and then add your new digit. But right now in the display, these things are just strings. We don't need it to be a number until we're actually doing the addition. So to tack something onto the end, that's just concatenation. So our job is easier dealing with strings. We can just set the text equal to current plus text. And that's just going to stick it on the right side. And we'll return from there. And if it's not a plus sign and it's not a digit, we're just going to return anyway, because they probably hit an equal sign or something silly. And that's end of state 1. And we got to do states 2, 3, and 4, but they're pretty much easier than state 1. But let's just see what this does. And this is going to be almost what we want completely for state 1. So there's our display, and we hit a 4, and a 7, a 6, and a 9, and it's adding these things on to the right. But the one little wrinkle is that 0 didn't go away and change into the 4. It just appended the 4 to the end of it. But that can be pretty easy to fix. So here's where we're doing the append. So what can we do in here? Yeah.
If digit equals 0,
Mm-hmm.
return.
Um.
Wait, no.
Yeah. Right idea.
If it equals 0, then turn current text into, or current
Yes.
digit text.
Yes. Don't append. Just replace. Right. So let's do this. If current equals 0. Then we'll just set the text equal to text. Else, we'll append. And now, first digit we hit replaces the 0, and then everything else appends.
And that fixes 0.
And it fixes 0 as a bonus, because if we just bang on the 0, it's actually replacing it, but it looks like it's ignoring it until we hit something non-zero, and then it acts normally. So we've got a way to input numbers now with a 10-button keypad. How cool is that? Right? And it's event-driven, and it's in a state machine, and it's all set up to handle the plus key, the equals key. State 3 is going to be exactly the same as state 1, just inputting. We just have to save this number and then print out the sum. All right, so let's do a 5-minute break. We'll finish this up after break, and then we'll talk about general reflections on this approach to programming.
Can you keep that up? So
Yeah, let me just turn off my, oh, I lost my Kazam. Okay, yeah, I'll leave that up. Thank you.
You're still allowed to do one-line if statements in Java, right?
Yeah,
Without brackets.
yeah, although I like brackets.
Okay. Okay, I'm assuming that it was just. That's always I know.
And then, yes. Yes. I don't know. There's one more. I just did middle and core. Just core, not UI. I think some of it comes with swing or something like that.
Yeah, maybe you can set that as why it did.
I think you may have wanted the selection and select swing.
Pull down.
I just did core. Oh, okay.
Maybe he didn't use that. Oh wait, text fields? How about text fields? I mean, I know you enter text, but it looks spiked though, right? There you go. That's the picture or not happening. Probably not the.
Or I need a round scene.
What if you look at that?
A parabolic scene. Well, the UI is
move too fast.
Yeah, why?
I want to see where he
Oh, it's a
could be interested.
For the display, what the actual, what the
Yeah.
He was moving friggin' click, man.
Just watch the video.
What?
Just rewind his, go to his computer.
Wait.
No, go to his computer and rewind the clip.
Yeah, right back. I'll just put it in the
Xbox record that.
Sorry, Nick, I got fingerprints in the screen.
Just trying to figure out the window folder. Cheeseburger.
No, it should just be a text this time. And then you. That's what I'm trying to find. It's in one of those. You had a handle.
The box is going in the trash once I finish typing these comments.
Those plus it just gives you the automatic background, but then again, it's just. Are those new glasses?
Do I want half an apple?
You want a quarter of an apple?
Oh.
Wow, that was really easy to reel you in with. I don't know.
How granular can you make me out? This is as low as I can go because after here I just start smashing.
Oh, you're just playing an apple.
Yeah.
Or sticks.
They're crisp
They
enough
just
to
hurt so
use.
bad.
Oh,
every
yeah,
time
go
you
back.
look, it's like,
Go here.
something,
You telling me what to do?
It's
Or go back to where
These
he's
are the
leaving
first
the
days. So
slide.
state is anyway first number,
Do you have
and then literally
flowers
just
on
strings.
it?
Okay, so
Got.
that's what this is. Setting your states.
Did you accept the terms?
Yeah.
He doesn't like me. I don't know how to use them.
I always want the ones where you just.
So what was the third one? And then second number and then get.
And then can you go to your display?
Yeah, hold on. I got to figure out how to get to
Camera was.
my Kazam window. Otherwise, all of this is lost. Hmm?
It's right here. So you go to design. Click on this and at the very top it's called
For
Revolution.
this time period.
So they're not there.
No.
We don't have a handle. I don't have a handle.
Okay, so it's the same as the other one, just gotta change it.
Wait, no, these are fine. What was this? How do we set that?
You need to die, you will. Go to sleep. Zero. Become blue Jedi light person.
And then right.
This should give me a 9. No.
Grab your burlap sack.
Not the second, because I got a problem here I got to fix. Can you wait 1 minute? Can you wait a minute?
Oh,
Can you wait a minute?
oh yeah.
I got to solve this before it blows up. That's okay.
So your text says.
Can you take your
Says
roller out?
unknown source.
Up to 20.
Pump 1 event for
Well, it's the same error,
Is it
then
fun?
maybe just.
Oh, yeah.
So you get a 30. Big number.
Can you take that granola and
Okay.
Hi. How's your mom? Just kidding. Hey, you're a pro.
I think you go to the John Rising School, thought there was no actual core to an apple, even though that's in fact the thing. You're just willing to eat the core.
Oh, there's definitely a core.
That's
Actually, see.
Yeah. Got it all good one?
This bottom part.
No.
Some people
You're-
present it.
Has to be about the
You
resolution.
can't even tell.
Wait, yours?
Yeah. Why is this so giant over here and then when I open the window, it's like itty bitty bitty left size.
Stuff.